air gap sensors are based on the toroids, and where you have a core here that is a carrier for the magnetic field, and the core the reluctance is a measure for the magnetic resistance, so how much this core tries to stop the magnetic field from moving in this core here. It's a product of two things. It's the reluctance in the core itself and in the air gap. If you have an example like this, that you have an air gap. So it's the sum of the metal part here and the air gap part here. And that is more or less the same as the air gap, because the air gap gives so high reluctance compared to what the metal would give. And the reluctance in the air gap is given by this expression, the length of the gap over the permeability of vacuum, so how vacuum carries magnetic field, and the cross-sectional area of the flux path. So these two elements here we can do very little about, but this is the length of the air gap, which will give the inductance in the next step. So this is a linear equation, a linear device where the inductance L is a function of Lg to the power of -1. So it's the inverse of the length of the air gap. These sensors are used where the air gap can be made very, very small, because it very soon becomes too large for any reasonable inductance to be measured. So it's for very, very, very small air gaps, those sensors.